Okay, your assignment was a cumulative practice test for chapters 1 through 4. Now, I expect that you probably had a little trouble with this. It's a lot of material. So what I'm going to do is I'm going to do, say, 3 questions at a time in separate videos. That way you can find the question that you're having trouble with a little bit easier. And also, I'm going to try to give you a hint along the way. So if you want to try the question and I give you that hint, then you can say, oh, I think I know what to do now. Anyway, so let's just get started. Here's question number 1. They're talking about skewness and the median and the mean. Now they have these houses in Sarasota, Florida, somewhere between 200,000 and 400,000, and they have a few houses that are very expensive. So those few houses are outliers. That's your hint. How do outliers affect skewness and the mean and the median? Okay, so quickly we'll do this. Don't forget, here's a box plot. Might look something like this. I'm not going to label it. I don't want these videos to be too long. So it might look something like this. And don't forget that right here, that line is the median, okay? The middle house. As far as all, half the houses are more expensive and exactly half the houses are less expensive, the median. And if we had these expensive houses like this, where would the mean go? Well, don't forget that the outliers affect the mean and would pull the mean in the direction of those outliers. So that looks like it is choice D. The distribution is most likely skewed to the right, and the mean is greater than the mean. Okay, there's question number 1. Let's go to question number 2. Okay, so here's your hint. Let's use inverse norm on the calculator. Now, if you're kind of like, oh, right, inverse norm. Yeah, what is that again? So the inverse norm tells us, say, for the 90th percentile, it'll say, well, the 90th percentile is how many standard deviations above the mean. So if you plug this into the calculator, it gives you 1.28. Okay, I'm going to draw a picture of what this situation looks like. Let's see here. Here's my normal curve, right? And the average height was 38. And let's see, 90th percentile was 40 inches, so she's 2 inches taller. Okay, so the distance here is 1.28 standard deviations above the mean. So essentially we say, okay, so 1.28 times some number, the standard deviation, which is what we don't know, is going to give us 2. This is 1.28 standard deviations above. So what is that number? So with simple algebra, right, we just divide this, we should get the answer is approximately 1.56. So 1.28 times 1.56 is right around 2. 1.56, which is choice E. Okay, moving on. Okay, so question number 3. They just want to know, how do adding and multiplying a set of numbers affect the mean and the standard deviation? So don't forget, the mean is affected by both, but the standard deviation is only affected by multiplying or dividing. So if we take a look at that, we have mean of 60, standard deviation of 18. So if you do, let's see, they're doubled and then 5 is subtracted. So letter B would be the answer, because the mean would be 115 after you double it and take 5 away. 2 times 60 is 120, minus 5 is 115. And then the standard deviation, if you double it, that's 36. But don't take 5 away. That doesn't affect the standard deviation, so it's going to be 36, which is choice B. There you go. That is number 3. Let's go to number 4. So this is a randomized block design. So what they do is they think that the outcome of the experiment may be different for female rats as it is for male rats. So they decide to group up the female rats, 4 of them, and group up the 4 male rats. They're going to take one from each group randomly, 1 random female and 1 random male, and then do the experiment and see what the results are. And do it again, 1 and 1. 1 randomly chosen female and 1 randomly chosen male. And again, 4 different times. So essentially, because you're picking one from each group, you have to have a male rat and a female rat. That is the essence of a block design. Okay, you're blocking them by gender. There's a block of female rats and there's a block of male rats. Okay, just to be clear. Now it looks like choice C just can't happen because one of the groups has 2 female rats. You can't do that. You're picking one from each group. Okay, so the answer is C. There you go. I think let's just do number 5 and I'll stop this video and go to the next group of questions. Okay, I'm going to go through each of the choices because I think this is a good review of this least square regression stuff. Now, I'm just going to assume that they came up with something that looks like this. Right? They take the weight of the mouse and they measure the tail, and as the weight increases, the length of the tail increases. Now, can we actually come up with an equation for that? And the answer is yes. It's right here. They give you that in the problem. Now, don't forget, the weight is the explanatory variable. The length is the response variable. In other words, the weight of the mouse explains how long the tail is. Choice A is incorrect. And don't forget, that's the one we're looking for, the one that is not correct. They flipped them. They're saying that the length of the tail explains how heavy the mouse is. So A is not correct. But let's keep going, because I think this is good. Letter B says the predicted tail length of the mouse that weighs 38 grams is 134 millimeters. So what you would do is take 3 times 38, add 20, and what do you get? And it is 134. So that's how you do that one. That is correct. Let's look at C. If we look at the least square regression line, the correlation is positive. Yes. Right here, it's a positive slope. So that's correct. Let's look at D. If you had measured them in, let's see, centimeters instead of millimeters, yes, the slope would go to 0.3. Now, what doesn't change is that R factor, right? The correlation coefficient, let's just say it's 0.94. That would not change if we change the units of measurement, okay? How closely this line is to all the points. That would not change, but the slope would change. And then letter E, one mouse weighed 29 grams and had a tail length of 100 millimeters. Well, if you plug it in, let's do that real quick. So 3 times 29 plus 20, what does that give us? So that gives us 107. So, for instance, maybe this is this dot right here, right? Our prediction is 7 below what the actual mouse was in that case. Okay, so I know that's a lot of stuff, but that's like a good review of least square regression. Okay, I'm going to go on to the next video. I'm going to stop this video here, and I'll do another group of videos in a second.